Hi, everybody. I'm still Ms. Lee, and we're going to go over the fourth type of equation that we're going over in this section. So solving equations, but we're doing exponential functions or exponential equations, but where they have a different base. Okay, so we're going to do solve for x, given that we have 3 to the 2x plus 1 equals 6 to the x minus 4. So I know you're looking at this and this seems similar to the previous one that was like same base where 3 and 6 look like they're related to each other. But the question is, can you write 3 and 6 with the same base? So can 6 be written as a power of 3? So 3 to what power equals 6? Well, that doesn't really work out quite nicely. And so we consider this different base. We consider this different base. Okay, so what we're going to go ahead and start by doing is taking the log of both sides. And you can pick any log you want. I generally either pick ln, the natural log, or the common log, so log base 10. So you want to take the log of both sides. And so I'm going to go ahead and use ln, natural log. And so we have ln of 3 to the power of 2x plus 1 equals ln of 6 to the power of x minus 4. Okay, so we're going to go ahead and use the power property, and bring the powers to be the coefficients of the logs. Okay, so use the power property. And so that 2x plus 1 goes in front. So we have 2x plus 1. The power now becomes the front of the logarithm. So 2x plus 1 times ln of 3 equals, and then we have x minus 4. And put those in parentheses for me, please, times ln of 6. Okay, so just a reiteration, what we did a second ago was we used the power property to bring the exponent to be the coefficient of the logarithm. So we took this x minus 4, and we brought it to the front, and that's like the coefficient. Okay, something that I also want you to be aware of is ln of 3 and ln of 6. These are both numbers. They're constants. So if you take the ln of 3, you're going to get a number. So for example, in our calculator, if we do ln of 3, you get a number. This is a number. So we treat this as an entire entity. Same with the ln of 6. This is going to be treated as an entity. Do not separate a number from the logarithm. Do not separate a logarithm from the argument. Those go together always. So keep this ln of 3 together, keep this ln of 6 together. Okay, and so we're going to go ahead and multiply this out, and so we're going to distribute. So meaning that we're going to take this ln of 3, we're going to distribute it to the 2x, and we're going to distribute it to the 1. Same with over here. We're going to take the ln of 6, distribute it to the 4, and then distribute it to the x minus, and then distribute it to the 4. Okay, so this is 2x times ln of 3 plus, and then ln of 3 times 1 is ln of 3 equals, and then we distribute the ln of 6 inside. So you have x times ln of 6 minus, and then 4 ln of 6. Okay, and so what you have here now is a regular algebraic equation. This is a regular algebraic equation. I know a lot of you are looking at it and you're like, oh no, this is not regular. There's ln's everywhere. That is actually okay, because all of the ln's that we see here, ln of 3, ln of 3, ln of 6, ln of 6, those are all numbers. They're all numbers. And so we treat them like they're numbers. So this is pretty much a linear equation because there's x and x. So you want to gather all the x terms to one side and all the non-x terms to the other side. Okay, so collect x terms on one side. And then you want to move all the non-x terms to the other side. So what I'm going to do is I'm going to try to get this 2x ln of 3. So this all goes together. I want to go ahead and move this to the other side of the equation. And then I want to take the 4 ln of 6 and I want to add that to the other side of the equation as well. So this one has a number in it, this one has an x in it. That's why we're kind of like switching them. So the ones with the numbers we bring to one side, ln of 3 is a number, and then anything with the x's we bring to the other side. Okay, so if we add the 4 ln of 6 to this side, you have ln of 3 plus 4 ln of 6 equals, and then you have x ln of 6 minus 2x ln of 3. All right, and so we'll go ahead and factor out the x from here. So you want to factor out the x from the side, whatever side you have your x on, you're going to factor out the x. So you have ln of 3 plus 4 ln of 6 on this side equals x times, in parentheses, because we're factoring out the x times ln of 6 minus, and then 2 ln of 3. Okay, so if you distribute this x back through, will you end up with this expression? Well, yes, they match up perfectly. Perfect. Okay, so again, remember the goal is to solve for x. And so we'll go ahead and divide both sides by everything that's being multiplied to the x. So what you're doing here is you're going to be isolating the x. Okay, so isolate x by dividing this from both sides. And so if you divide both sides by ln of 6 minus 2 ln of 3, you get x equals, and then we're leaving this, so ln of 3 plus 4 ln of 6 divided by ln of 6 minus 2 ln of 3. Okay, just to repeat, oopsies, this was divided to the other side here. Okay, and so what we're going to do is, because this is kind of an ugly expression, we're going to go ahead and put this into our calculators. So remember, put the entire numerator in parentheses and the entire denominator in parentheses. So we have in parentheses, and then we're doing just the numerator, ln of 3 plus 4 ln of 6. And see, there's two parentheses, one to close out the ln and one to close out the entire numerator, divided by, and then again in parentheses, and then the entire denominator. So that's ln of 6 minus, and then oopsies, close the parentheses. So don't forget to close the parentheses. This closes the ln parentheses, and then minus 2 ln of 3. And then we close the ln parentheses, and we close the parentheses for the denominator, and we get an answer. Okay, so our answer is approximately equal to negative 20.386. So we round to the third decimal place in this class, always third decimal place. So negative 20.386 is the approximation for this answer here, and you have to remember to check. So I'm going to go ahead and check on my calculator because this is far too difficult to check by hand. So what you're going to want to do is store this. So there's two ways you can do this. You can either just leave it like this, and you can use like the answer button, which is the second negative, and that gets you the answer button, or you can just store this into a variable and then plug it into the original equation. So what I'm going to do is I'm going to store this into a letter, so A, because, you know, first letter, why not? And then I'm going to type this out using A. So 3 to the power of 2A plus 1, and we're asking, does that equal 6 to the power of 2, oh, not 2A, A minus 4. Does that equal? Well, yes, those look like the same number to me. And again, you don't have to use a graphing calculator. This is a TI-84. You can use Desmos or any graphing calculator of your choice. So this did check out and it did work. And so this is our final answer. So negative 20.386. Okay, so that's how you solve when your two bases are different bases, Okay, happy practicing. Happy day.